For US EVA 33, both crew members will start out at the US joint airlock. We have Chell here in the suit with the red stripes, and Scott will have the suit with the white stripes. Scott will bring out a crew lock bag that has all the tools from inside the space station that they'll need to use on this EVA. Chell will pick out a vent tool bag that's on the zenith portion of the crew lock, and he'll take that out to the work site. From here, he'll head all the way out to P6, and he'll set up what we call a slingshot. It's a way to get the maximum length out of your tether. He'll translate out to P6, past the trailing thermal control radiator, the ticker. He'll stow the vent tool bag at this location. And this will be set up later in the EVA. And then he'll head over to the fluid quick disconnect coupler. Scott will be right behind him. They'll work together to remove a cover here, and then they'll drive a bolt which will open a valve and allow flow into the photovoltaic radiator that you see on the right side of this view. They'll work together to get the cover back on, and then Scott will head over to the P3, P4 jumper, and then Chell will stay behind at this work site, and he'll break the connection, close the valves that link the photovoltaic thermal control system and the early external thermal control system. He'll then stow one of those jumpers to keep it protected for the future. Here we have Scott at the solar alpha rotary joint. He's going to install the jumper across the Sarge. This will complete the fill pipeline. And meanwhile, Chell is going to start setting up the vent tool and vent tool extender. We want to have this set up because to make sure that it's in good working order before we begin the fill. We're going to need to vent the fill line to prevent overpressurization. So we don't want to lock that line up with ammonia in it. At this point, we'll be ready to start the fill. We have Scott over at the ammonia tank. He'll reposition a jumper, and that will route ammonia from the ammonia tank into the fill line. After a short leak check, as long as everything is successful there, we'll have Chell mate the P5, P6 jumper over to P6, and this will start the fill of the early external thermal control system. From there, he'll head back over to the early ammonia servicer jumpers. He'll open a valve, and that will initiate the fill of the photovoltaic thermal control system. We expect this to take about 20 minutes. So while that fill is going on, we're going to have Chell retract the trailing thermal control radiator. He'll be using a pistol grip tool, which is basically an EVA version of a cordless drill. He'll drive a bolt about 50 turns, and it'll retract the radiator. Once this is complete, we expect the fill to be finished as well. So Chell will head back to the early ammonia servicer jumpers one last time. He'll close that connection between the two systems and stow them in a safe configuration and leave those two systems isolated. He'll then pick up the bags that Scott left behind there. He'll move them to a new location that's more convenient for this portion of the EVA. And then he'll head down to the P5, P6 jumper. He'll break that connection in the fill line and route that to the vent tool and vent tool extender, and this will begin the venting of the fill line. So you can see here the vent tool and vent tool extender. You see a cone showing where we expect to vent out the ammonia from the system. Here you can see some footage from STS-134 where Drew Feustel did the exact same task. They did a fill of this system as well. You can see he just opened the valve to the vent tool, and you'll see him look back over his shoulder, and you can see the venting of ammonia out of the system. So we expect to have a very similar view on US EVA 33. Expect that vent to take about 17 minutes to fully get all the ammonia out of the line. Meanwhile, we'll have Scott head over to the starboard CETA cart. He'll be reconfiguring this CETA cart so that we can take the mobile transporter to work site 1 and still rotate the Sarge. So he's going to fold over 2 brake handles and secure those with a tether. From there, he'll move over to the coupler. He'll remove that, and he'll attach it to the swing arm. And he'll drive 4 bolts to release the swing arm. And we'll now have the CETA cart in a good configuration to go to work site 1. He'll translate to the aft side of station near the ammonia tank where he was working earlier. And he'll stow that swing arm on a tool we call the Terra. Now, this is a tool we haven't really used at all in the past, but we finally found a use for it, a stowage location for this swing arm. So he'll stow it there, then both crew members will head back to the solar alpha rotary joint. Now, we've seen some vibrations in the data that we get down to the ground, and we think that's because there's a strut that's loose. So the crew members are going to both work and they're going to drive a bolt on two different struts. I think it'll just be a fraction of a turn, but hopefully that'll fix the vibration issue that we've seen. We'll then have Scott head forward. He'll remove the P3, P4 jumper across the Sarge. Once this is removed and stowed, we'll be able to rotate the solar alpha rotary joint again at the end of the EVA. Then Chell will begin work on cleaning up the vent tool and vent tool extender. Again, all the ammonia has been vented out of these lines at this point. So he'll demate the P5 to P6 jumper from the vent tool. He'll stow that on a dummy, and then he'll begin coiling up the vent tool and vent tool extender. He'll pack that all back in its bag. This is a bag that remains outside because it has ammonia in it. We don't want to bring that back inside, so he'll move that back to the airlock at the end of the EVA. Now both crew members will meet up at the ticker, and they'll work together to install 6 cinches. So these cinches will compress the radiator, hold it into place, prevent it from being damaged. Here you can see on US EVA 7 the compression the crew needs to do in order to get a cinch installed. I think it's about 10 pounds of force to push down on that radiator. The crew will then work together to install a thermal cover over the ticker. This will protect it from extreme thermal environments. Here we see a crew member working in one of our NBL training sessions to get that thermal cover installed over the ticker. It's definitely something that it takes 2 people to do. There is another crew member in the top view here. So one guy zenith, one guy nadir. Both crew members will pick up their respective bags and head back in to the airlock. Here we see Scott with the vent tool extender bag. He'll stow that on the zenith portion of the airlock. Chell will then, on his way back in, reconfigure the jumper at the ammonia tank. He'll move it to the vent position. In case we ever do get an overpressurization in the system, we have the ability to vent overboard if we ever needed to do that. Chell will then translate back towards the airlock. He'll pick up Scott's tether at the slingshot location. He'll come back in on Scott's tether, and he'll have the 2 crew lock bags with him that are bundled together. He'll ingress the airlock, and that will conclude US EVA 33.